Hello, my name is Caleb Brady, and today I will be going over my program for the upload assignment S1 search benchmarks. The goal of this was to create an array of 500 random integers using the random class, and then sort the array using quicksort and save the result of the new array. And we already got a quick sort program and an example of what quick sort is, so I just kind of like took that code and basically just rewrote it and saved it as a file. So that's why I did that. I'll show what it looks like in a second. And then we gotta run a program that has the demo program, which does a search and has to find where a certain integer is from the array before it's sorted, and then find it again once it's sorted. And so let's go see what this looks like. So first things first, the quick sort. It's just a simple quick sort program where it has the array. It takes on the array, 0, which would be the starting point of each array, and then the length minus 1, which is the just basic length of the array if you're starting at 0. So then we have to find the pivot, and then it's just a simple quick sort from there. But the program that we're going to be exampling with is this here, which I just named search benchmarks. I named this quick sorter just so if I need to do a quick sort in future programming stuff, I can just simply go back to it. Nothing in here is named, so I can just refer to it whenever I need to. Homework that helps later on. So here we create a new array. I just named it big because, well, when you're considering all this Java stuff, 500 is a lot of numbers. Especially I did a little experiment here. I had it so it would print out each value of the array so you could double check its quick sort. I will show what that looks like once, but it takes up way too much space, so I won't be doing that every time I run this through. So what it does, it makes the array, and then it assigns each number of the array to a random number, and I just kept it simple. I just kept it between random number up to 1,000, and not including 0. So we'll just start at 1 and go all the way up to 1,000 using math.random. So then before, and then I saved what the array is as an integer. No, that's not what I did. I'm reading this wrong. What I did here is I took a random spot in the array. Since the array is 500 long, I did between 500 and 1, so 500 starting at 1. So it'd go math.random, so it'd pick, say, 372, or what number 372 is, and then it would bring that number back, and it would be saved as before. And I make sure to save the spot where before is, before the array is sorted. So then it just prints out the number is located in, I can actually just don't have to do that. I can do that or just big before. It accomplishes the same thing as just saying save. And it will say is located at the before spot of the array before it's sorted. Then it takes the array, which is all it's needed to do in the quick sort, and then brings it back sorted. And then we get the after, and I did a find location. So in the find location, what it does is it goes through each number of the 500s, and if it checks to see if it's equal to saved, and then it returns the saved value. If not, it just returns the last value, which that will be obvious if it is a problem, or if it's not. Then in the end, it just says what the position is after the array I sorted. I'll just show what that looks like right now before I show all the before and after sorted. So there we go. Number 484 is located at the 473 spot of the array before it's sorted. After it's sorted, it's located at the 258 spot. And when you got an array made of 500 numbers, that's pretty believable. So now I'll show what this looks like when you get all the numbers. It's a huge mess, but it's pretty cool. So we start here. So that is located at 413. If we look around 413, we should see 209. Actually, I'm not going to look through all that for 413. But you can see it starts off all jumbled up, just a bunch of whole random numbers. And after it's sorted, it's all in order. And we see that 209 is located in the 89th spot. I'll just revert that back so we aren't getting all those numbers. And we'll run this 8 more times, just to make sure it works. Yep, that seems about right. Again, 66 is a low number compared to 1,000. And the 500 different spots. What's that? I think 6. Let's say this is 5. 4. 3. 2. 1. And there we go. That's the program. I hope you enjoyed the video.